All right. Good morning, everyone. So I see we have guests in the house. Welcome, everyone, to our final presentations. We have 5 teams going today. We had 20 projects this semester overall, so our presentations are going to run throughout the week. We have 5 going today. We're going to start with AI Auditors, and then it's going to follow with Colorize, SciComm Center, Wonder Lab, and we'll end with Portal Harmony. So you have 15 minutes, so producers keep an eye on me, and then we have 5 minutes Q&A. So faculty get first dibs, so if anybody has any questions, just raise your hand, and you all give us a nice final presentation.
Hi everyone, welcome to AI Auditors' final presentation. So I'm Jacob, the producer of the team, and this is our team for today, for this semester. Yeah, so AI Auditors, we are partnered with Ken from CMU Human-Computer Interaction Institute this semester. So he's mainly focusing on AI research. So our client needs our help in the research of AI fairness to create a game with a purpose, similar to the concept of the ESP game. So our targeted demographics will be young adults aged 20s to 30s. And these are our metrics that we are following through for this semester. Our final deliverable this semester will be sieving out a harmful bias in an AI toxicity model through gameplay using a web-based multiplayer game with the capability to store useful data. Sounds challenging? It is definitely challenging. So I'll pass the time now to Shirley, who will explain more about the gameplay.
Thank you, Jacob. Hello, everyone. And here are our little robot teachers. Since you have a pretty serious concept, we want the players to feel relaxed while watching these little robots throughout the gameplay. And in the beginning, we have worked with our clients to our storyline and wording of the storyboard, and we finally landed on the 3rd version. And now I'm going to guide you through our story to better understanding our purpose behind the game. Bots are being used today to help moderate contents online, and they try to find toxic comments for automatic deletion. To learn which comments to delete, they will look through people's posts along with human ratings of how toxic they are. But there's a problem. They aren't really smart, and they don't really have any understanding of social, cultural, and historical context. In some cases, it can be harmless, like the example inside the picture. At the left side, you can see if the big data, that means most of the people believe that this apple is a cat, then the bots will think this is really a cat. Even in reality, this is an apple. And in some cases, it can really harm people. For example, inside the picture, the bots recognize 70% of text with queer in it is negative. So they will think, oh, maybe queer equals to toxic. And then they will delete all the tags screening it as toxic. Then LGBTQ people will be harmed because of their comments are being erased by the bots. Can we help the bots to learn to avoid mistakes like this? We have bots college teaching program here for you. And we also have a special teaching tools here, and our bots use these special cards to learn. And we are having a lot of teachers this year. You are not alone. Welcome. And in this page, you will be able to create your own username and the password to play our game. And now I'm going to pass it to Lynn to explain our tutorial.
Okay, so before we start, there are some key concepts that we want to clarify to our players. We have tried several interactive tutorials to test which version is easier for players to understand. First, we bring out the idea of what is toxic and what is non-toxic. In the game, players will have to create and identify non-toxic posts. Like in this line, Muslims are not stupid. As an example, most people will see it as a non-toxic post. However, bots will label it as toxic as they detected the keywords Muslims, which often appear with toxic sentences. They will delete all comments like this, and that might be unfair and harmful to a group if the deletion is biased. We then want players to choose which group that will be harmed if this kind of post is deleted, to push players to understand our key concept. So, to make it clear, we want players to understand that bots will delete comments that are wrongly labeled as toxic, and that deletion will be unfair and harmful to a group. That is why we have the bot college and allow players to teach and improve the bots. After understanding that, we'll guide players through the multiplayer part, where players will first pick a card from their deck, and that is the most harmful deletion card. So in this case, we have 3 cards here. Your joke is killing me, blacks fight prejudice all the time, and kill me with a kindness. Which one would you choose to be the most harmful deletion card? Well, probably the middle one, which says black fights prejudice all the time, is unfair and harmful to the blacks if it is wrongly deleted. So other teachers are doing this at the same time, and everyone will pick a card from their card deck and place it on the table. Now it is time for everyone to vote for the most harmful deletion card among all cards here. It is okay to be subjective since we're going to collect all the voting data. So at this part, players will need to pick the most harmful deletion card twice. One is among their card deck, and one is among all the cards on the table picked by other teachers. So we'll dive into this part later. You might have some questions about how the cards are created. We'll talk about this part, and I'll pass the time to Hannah.
We will be doing a live demo for part 1. When the player first clicks on card creation, they will see this cutscene with posts from all over the world being checked and labeled as non-toxic. The scene is meant to emphasize the situation that we outlined at the to take into the multiplayer game. Given that it is difficult for players to create multiple cards at once, before starting the multiplayer game, we generated 200 phrases, all of which were misidentified as toxic by the AI, but vary in harmfulness levels for players to use as default cards. Now I will hand it over to Eliza in order to talk about the multiplayer game.
So, after the player creates their own deck, they're able to use this deck and play with others. Due to the time constraint here, we are not using a live demo on the multiplayer part, and we will use a video instead. As you see, after the players enter the Play with Others mode, they will enter the lobby, where they can either choose to join or create their own game room. Anyone who creates the room will become the host, and the host can decide when to start the game. And the game starts. Here we choose the card, Asians are non-stupid. It is clearly a harmless card, and if deleted, will be harmful to Asians. And we enter the voting time. In the voting time, we need to select the card which is the most wrongly deleted and would be harmful to a group. And this time we chose Don't Be Ashamed to be Asians. It's also clearly non-toxic and would be harmful to Asian if deleted. As you see, our card get 4 votes, so we get 4 points. And we enter the next round. This time we are using a skill which allows us to use a card twice because we found one of our cards super useful. Here we choose the card Proud to be Asexual. This is a card that will be harmful to asexual people if wrongly deleted, and we enter the voting time. We vote Proud to be Asian Queer, because this card, also non-toxic, but if deleted, will be harmful to both Asian and queer people. And let's see, our card again get 4 votes, so we get 4 points. And we win the game. The purpose of the multiplayer part is to find out what other people think the most wrongly deleted versions of the AI model is and collect the AI biases. Also, it encourages people to go back to part 1 and create more cards, which help for them to win. And then I'll pass the time to Jisa to talk about the tech part.
Thank you, Eliza. So our clients asked us to make a game with a purpose. And the purpose was to collect data from players for AI researchers. To achieve the goal, we used various kinds of technologies. To make a game, we used Unity, and we published our game on itch.io. And we connected our game with Hugging Face to use the AI model. And we used Photon to host a multiplayer game. And finally, we needed a place to store all the data generated by players. So we used Firebase upon the client's request. And we saved the data in a reusable format so researchers can easily manipulate and reuse them. First, we saved the harmful biases found by players. We store the timestamp, content, and toxicity level. Second, we save the gameplay data. We store the game, when a game starts, we store the timestamp and player's ID. Third, we store the auditing data. By using this data, researchers can understand biases and people's thoughts on them. And all data are connected, so researchers can deeply understand the data. Final data is demographics. It helps researchers deeply study the relationships between the biases and demographics. Now, I'll pass it to Tianyin.
Thank you. So the playtesting, we tested and collected feedback for more than 20 people. And we found what went well was that people's perception about the robot character was very positive. And they found the interaction to be easy and the interface to be usable. But what didn't work so well is that people had an issue understanding what to do throughout the game, especially in the card creation stage. And the conclusion that is we need more clarification and clearer goal presented to the player. And another interesting finding is that we find people who started from the auditing multiplayer game and then the card creation had less confusion than the player who started card creation directly. So we started rethinking about the game flow. So the old structure was that after the storyboard, people can go to either the card creation or the multiplayer auditing game. But now in this new structure, where after the storyboard, people can go through a list of short tutorials where they can learn more about the basic concepts and play a modded, like multiplayer auditing game with or like fake players. And then they can go to either the card creation or auditing. So that helps to clarify the flow and help people to set up their goal, which makes the context and the goal very clear, which is to create cards that can help players get the most votes in the multiplayer game. We also increase the clarity of the game by keep reinforcing the relatable context that the robots are deleting messages biasly online. And we also break a very complicated task into very simple steps. And we give more visual cues and feedback so the player can learn by doing throughout the game. And then finally, in the soft playtest, we found our faculty players to feel very positive about this game, even though in the beginning of the semester, they were reluctant about whether this concept will get through. But now they feel they can understand well because of the story and the breakdown, and they find the concept to be meaningful and impactful. Then I'll pass back to Jacob.
Thank you, Tian-Ying. Yeah, so we want to thank everyone for going above and beyond in helping us to conquer this challenging project. So finally, this is our last slide where we want to just summarize what we have up to this point. So we have an online playable link where it's accessible to everyone and comprehensive tech document and code documentation to hand off to our client. On top of that, presenting to you AI Auditors, where we support users to have fun while sieving out harmful biases from an AI toxicity model as a byproduct of gameplay. Yeah, we are open for questions. Thank you.
So roughly how many players have you had so far?
So we had like different players in different playtests and in stage. So the biggest playtest we had was on about 22 people, and smaller ones include about between 5 or 6 and others.
So is there a plan to put the game out to be played more broadly?
Oh yes, we are going to pass this to our client as an AI research group, and they will release it to more people so that they can test.
Okay, thanks.
Thanks. I think this is really interesting. I had a few questions. One is, I'm curious how much data your client needs for this to be useful. So like how many players would need to play it for how many hours, or I don't know how to measure that. Well, I'll just, ask that first. That should be an easy one.
Yeah, so the main goal is to collect data from the diverse people because they are HCCIA people, so they can gather data from computer-based people, but they want to collect data from a real world of different people, so that was the main purpose.
Okay, but my question is, like, if one person plays it for an hour once, that's not going to be enough data. Do you have any idea of the magnitude of data you would need in order to retrain those bots successfully?
That's a very good question. Actually, the feedback we got from the player is that they care more about the quality of the data instead of the quantity. Because in the past, they've had other tools that they built to try to collect the data. But the thing what they found is that most of the data they found was focused on the mistake of the AI models instead of focusing on the bias. So the mistakes can happen when AI make mistake, but it's not like super harmful. It was more used to be like identifying apple as a cat, that kind of thing. But so the project we are doing this semester is mainly focused on trying to see the bias from the other kinds of mistakes. So that's the part we really care about.
Okay. Another question I had is there any notion of people who might intentionally answer in incorrect ways to frustrate exactly the thing that you're trying to, and how would you deal with that? Or do you have any way of responding to that?
So that has always come up, and obviously there's no way to, at least that we could come up with, to completely 100% guard against that. But the hope is that if we can that's where part 2 comes in, where if someone were to make a card like that and then put it in the actual game, the hope would be that it wouldn't get any votes, so we would know that it's kind of a incorrect data point, or, you know, like probably not, someone was either trying to mess with us, or it's obviously not seen that way by a ton of people.
Okay.
I just want to add on one point. Yeah, because we face this issue, so that's why we try to very hard to elaborate on the tutorial and the storyboard so that we can really bring it across. We also have one element where we have purposely put out like toxic cards for player to try to vote, and then we tell them that, oh, this is a toxic card, so you cannot do this. So due to time constraint, we didn't show all this. Yeah, but we have a few mechanisms put in place to try to solve this issue, but it won't be like 100%, but we did talk through and try to put some measures into it. Okay, thank you.
Hello? Shao, can you hear us?
Yeah, I can hear you.
Great. All right.
Yeah, yes.
Okay. All righty. Well, good morning, everybody, and welcome to Colorize's finals presentation. This is the Colorize team. Our faculty advisor is Ricardo Washington. Our client is Luke Harris, the Director for Center for Arts and Education at West Liberty University. We've also been collaborating with our 2 graduate assistants, Lisa McGee and Catherine Nelson. Now, Colorize's goal is to create hardware prototypes and documentation that will foster engagement in colored light and light-colored mixing in elementary school students K through 2nd grade. So why light and why hardware? Well, with light, it's less commonly taught in schools, and it leads to more innovation with the hardware. And as for hardware, it demonstrates the concepts of light better, and it was our client's preference. We've playtested at 4 sites with approximately 60 kids over the semester, and it's been pretty integral to our process. And after those playtests, we came away with a few different key pillars that we want our project to hit. One is we want autonomous play with room for guidance. We want it to be easy to set up for the teacher, and we want to get kids excited about the activity. So what exactly did we make? We made 4 activities: the color whiteboard activity, the light strip activity, shadow puppets, and the color wheel activity. I'll now go into a little bit more depth on the color whiteboard activity. The whiteboard activity has kids pressing red, green, and blue latching buttons to change the color of the DMX light that will shine onto the whiteboard. They can press multiple buttons to mix colors, they can press all 3 to create white, and the idea is that they can do drawings on the whiteboard and see how the light affects those drawings. For instance, when you shine red light onto red markers, the markers tend to disappear a little bit. Our design goal with this activity is to give autonomy to the kids to control the lights while also experimenting with absorption and reflection. And what we found is this is a great platform for them to start discovering those primary and secondary colors. They can all work together under some guidance, and they even create lines on the boards to create their own space. And they're really getting into the switching of the colors and seeing how it changes their drawings, and they experiment a lot with that. And we believe this activity is a success because kids can actually see real physical lights mixing on the board. They can see the channels red and green on the DMX light and see it mixing. It's really open-ended and allows for a lot of autonomy. They can make whatever drawings they want. They can change to whatever colors they want. And kids were really curious about why the light was changing the drawings in the first place. I'll now pass it on to Wizard to talk about the light strip activity.
Thanks, Max. So in this activity, we provide the 3 buttons, R, G, B, to allow the kids press the button and light up LED along the light strip. When they press 2 buttons simultaneously, they can create secondary colors. When they press 3 buttons, they can light up white light. And when they complete the light strip, it will play back a sound based on the color input. Each color presents 1 pitch, and the white is the rest, allow the kids to create their own songs. The design goal of these activities, we want the kids experiment with adaptive secondary color mixing, and we add the sound and notations, encourage them to create more secondary colors and try different color combinations. During the playtesting, they were first exploring primary and secondary colors, and then they were making music together based on our notations. And finally, they'll create their own songs. The success of this activity is a good head-effect activity. Kids were creating the music, but actually they are exploring the light color mixing. Also, there are more engagement by we providing more engagement operations when we provide the sound and notations. When during playtesting, when they complete 1 notation, they will really complete all 3. And some of them will work together. 1 is reading the rotations, 1 is pressing the buttons, and 1 is pointing along the light strip, prevent mismatching. Even though we provide a target or notations, kids still creative and create their own songs and patterns. Such as some kids will create the silent songs, create all white lights. Or they will taking turns press the buttons and then listen to the music they created together. Based on this success, this activity is kids' favorite one. They are willing playing again and again and understanding the light color mixing naturally. Now I'll pass to Qing.
Thank you, Wizard. And I'm going to talk about our next activity, which is Shadow Puppet. So this activity is using RGB lights and shadow puppets to do shadow projection on white screen, which enables the kids to learn through play. And through our play testing, the kids had a very engaging experience. And this activity provided an intuitive learning experience to learn how the color mixing different with the traditional pigment mixing. And our design goal for this activity is to let the kids experiment with the effect of shadows on light color mixing. And what we're going to deliver is first an initial equipment list and also example prompts, and also the initial equipments, and also set of different themed shadow puppets to allow the kids to start this creative activity. And this is the puppet samples. They're divided to movable samples and also solid samples. And how we found its success is first, the equipment is very easy to purchase and set up. And also the kids are very engaging with its storytelling potential. And last, the kids see real light mixing and casting shadows and how it different with the traditional pigment color mixing. And next, I'm going to hand it to Shell.
Thank you, Chin. Now I'm going to talk about the color wheel activity. For the color wheel activity, kids will use the rotary knob and the push button to submit primary colors. And depending on the proportion of primary colors they submit, they will make secondary and tertiary colors. And the goal of this activity is to complete the color wheel. And when completed, there's a light show in the end. The goal for this activity is to let kids experiment with tertiary colors and incorporate the color wheel. This activity also has 2 modes. The first mode is fill the color wheel mode. In this mode, kids will learn where the tertiary colors, such as orange and pink, come from, and also encourage problem solving. The second mode is make your own mode. In this mode, kids will create their own version of color wheel with whatever color they like. And this mode is more creative and more sandboxy. During playtest, we saw that kids were working together to solve the problem. They also created their own strategies, such as putting in the primary colors first. They will also refer to other activities to find hints to solve the color wheel. We think this activity is successful because we really saw kids trying to solve the puzzle together. Having the two modes also enable problem solving and creativity in the same box. Also, incorporating the color wheel allows for easy creation of lesson plans for teachers. Now I'm going to talk a little bit more about our documentation. The goals for our documentation is to first facilitate teachers and kids to use the activities. We also think it should give context for creation of lesson plans or expansion of the project. And we want to allow replication of the activities in the future. So we have these deliverables. We have the user guides and the tutorial videos that facilitate our users. And we have instruction per activity, the color theory guide that goes into each activity into detail. And we have electronic schematics, code, and design documentation to help people if they want to replicate our activities. Now I'm going to pass it on to Caitlin.
Thanks. So I'm going to talk about our process a little bit. We start off by brainstorming several different activities, and for the ones we think have promise, we create initial designs for. We then research these to figure out what kinds of materials they'd need and whether they'd work with the concepts we actually want to create. And if all goes well, we create a prototype and playtest it. From these playtests, we use the feedback to redesign or create new prototypes for each activity, and we did this multiple times. During the process, we ran into some different difficulties. For example, our slider activity. With this activity, we found out it wasn't really technologically feasible to do in the time period, so we ended up having to cut it. But actually, by cutting it, we opened up time for our more engaging activities, such as the color wheel. Speaking of the color wheel, I will now use it as an example of our process. So to remind everybody, the color wheel's goal is to experiment with tertiary color mixing in the color wheel. So it had many different forms before we landed on the color wheel. It started out with a puzzle, but it was too much negative feedback and not enough understanding. So we made it a sandbox activity, but there wasn't really any drive for replayability. So we tried adding a form factor to make it more replayable, but even in the hardware form, there was no real reason to use the tertiaries over the secondaries and primaries. So we ended up with the color wheel. During this, we had some surprises. Hardware was always more successful than software at getting across the concepts. And the other thing is UI can vastly change the experience. 3 buttons worked for the LED light strip and the whiteboard, but it did not work for this activity. We also had a couple of challenges. The first one was form factor. This was the biggest challenge for this activity, but by just creating more prototypes and playtesting often, we managed to come up with the color wheel in the end. The next one is getting the students to use the activity properly, and by switching out for a rotary knob and a button, we managed to keep them from using the UI incorrectly, because the other two, they used the 3 buttons. You were allowed to hit 2 buttons, and we only wanted them to hit 1. The final thing was getting an activity that would work well for lesson plans. By creating the color wheel, we went back to the color theory basics, which allowed us to make it easy for lesson plans. I will now pass it off to Bob for closing statements.
Thanks, Caitlin. So we're going to go over the wrap-up of this semester. So there's a few lessons that we learned. We had a lot of fancy tech, but that didn't really guarantee that the kids were going to be mostly engaged with it. A key example of this is the shadow puppets. We had tablets with software and games on, but kids always wanted to play with the puppets and see the lights themselves. The kids were willing to experiment and just try and fail. As soon as they saw a box with 3 buttons, they were just pressing all of them at once, 2 at once, 1 at once, and trying to ask the questions of why is it changing the effects of that drawing? Why is this puppet having 3 shadows instead of 2? And there was also assumptions in software that didn't really translate to hardware. For example, when we made a Unity game with 3 buttons on an interface, we were limited by the mouse interaction. So you can only click 1 button at a time. But as soon as that UI became hardware, it opened a whole lot of problems afterwards. So we were successful this semester
And the key reasons why we think that is that we were playtesting often and very frequently. We were working with kids, which was gratifying by itself, and it really allowed us to have fun along with them. And there was a very good rapport with the client, and they had some clear goals. They really set up a fence for us to explore, and they trusted us with their discovery process. And at the end of the day, when we had an idea and it went to the physical space, there was a gratification in that for us. So at the end of the day, we're delivering 4 activities, and they can be used separately or in unison. There's going to be user guides and prompts for teachers, which has already been tested out with them, and they don't really need input from us to use it. There's technical documentation if they want to replicate any of these activities. There's also bills of materials and basically purchase lists if anything breaks down. There's also video tutorials for a quick startup guide if they don't want to go through the documentation real quick. So the next steps, these 4 activities are going to rest at the West Liberty University Center. And it's going to be available to be partnered and loaned out to schools if need be. At the end of the day, we created a platform for teachers to create their own curriculums around these activities. And also, if the center wants, they can replicate these activities if they pair up with the right programs, such as future ETC projects. At the end of the day, there's many people we want to thank along the way, and these are just a few of them. We are now open for questions. Oh, Mike. All right.
There's just a little bit of tension with one claim that hardware is much better than software and another claim that fancy tech isn't always the best. So I'm just curious, if you had the color wheel as is with your hardware and you had the same interactions just on an iPad through a touch interface, what do you think would happen with kids K through 2?
It wouldn't be the same, simply because they already have an iPad at home, so it's nothing different for them at the activity space. And also the tactility of things is much more different. The fact that they're pressing a button, getting that feedback, gives them a much more enjoyment. And the client actually does agree with this, and they were pushing for hardware from the start. So were we on the side.
Also, during playtesting, we saw whenever it was on software, the concepts were not getting across as well because they'd mix it up with subtractive mixing rather than additive.
All right, cool. Oh, at the back. All right, I'll pass the mic.
So just a quick one. Since you all are using hardware, I'm wondering like how long it takes to create like one hardware piece and how many students can it be catered for? Yeah.
Okay, so hardware, the limitation for that is ordering the parts specifically. If we get all the hardware done, it usually takes a week if we know exactly what we're making. Are you saying how many students can play on an activity?
Yeah, like how many hardwares do you all produce like for this project or
Okay.
cater to how many?
Yeah, so there's one of each at the moment, but for each of these, multiple people can play. Example, the whiteboard, we can have at most, I said 2 people? Two is generally the best. Color wheel, we can have at most 2 as well. For the shadow puppets, it's basically how big their space is. So that's really kind of, and it's easily replicable because it's an equipment list. So if they have this entire white wall they want to put on, they just have to duplicate it. You can have at most 4 on a set, but it can go up to 10 if they have it properly replicated. Does that answer the question, Jacob?
Yeah, just a follow-up question. I'm wondering like how long does it take for one experience? Like do they play through everything or it's open, they can just play one, and how long will it take?
So I'll probably leave that to the designer to talk about that more.
Yeah, so one of our design goals was to create short experiences, so they'll take about 15 minutes each at most. They may take longer if the student decides to like think on their ideas and what they want to do more, but we're aiming for 15 minutes per.
Okay, yeah, thank you.
Yeah, thank you. I think this is really strong work. And I just wanted to know, obviously you're handing all of this to your client. I want to know if you have plans for putting it in a totally public forum like Instructables or something, so that
nice.
people in lots of places can reproduce or modify your work.
So for putting it on Instructables, that has not really crossed our mind. There is a discussion with John Baelish in the afternoon to have these activities be replicated at the ETC. So we're seeing how that would go. as a public form factor at the moment, our site is public, and these are going to be downloaded instructions there. Putting them on Instructables, that's a bigger discussion that we haven't really touched on.
Yeah, I would encourage you to open source this in as many venues as possible. 'Cause I think it's really great work, and many people could reproduce and build on it.
All right, thank you, Zach.
And one more?
We can take it. Oh, Mo, the consultant himself.
What would you do differently?
I will open it to the team. Because for me, there's nothing.
I knew you were going to say that. That's why I asked.
One thing that we have discussed this a few times. One thing that we did talk about doing differently is that we kind of wish we had decided earlier on that, like, for example, the sliders didn't have enough engagement, and we had put more focus on the color wheel earlier, so we wouldn't have had such like a crunch at the end to try to make it what it is.
Building at hardware ETC wasn't the bestly prepared. We were really going to ideate to get hardware stuff and basic electronics to prototype things, and things always had to be ordered in. Yeah, and there was certain things that have been kind of dusted off since the COVID times at the ETC, so the shop isn't in the best shape that it was. Yeah. Cool.
All right, thanks.
Thank you. Thank you, Shao.
Yeah.
The mics are off. Thank you, Shao. And the Zoom call.
Are we ready to begin? Cool. Hello and welcome. We are SciComm Center, and this is our team. So for this semester, we worked with the ASTC, or Association of Science and Technology Centers, in order to create a game that will help facilitate conversation between their members. This game will be played at their 2022 annual conference here in Pittsburgh, Pennsylvania. And as such, our target demographic is expected to be leaders and experts in this particular sector. So the game that we have created is called Pitch Party, and it is a social game where players take on the role of funder and designer. So now we'll quickly demonstrate how we play this game. So if I am at the conference, I may see a poster similar to this one, and I will look at this poster, find some other people who are interested in playing, and then we will use our phones to scan this QR code right here, and it will open up this web page. And on this web page, I can choose to start or review the rules and then start. Once I've started, one of our group members will be the funder, and everyone else will be a designer. As a funder, I will receive a random topic and requirement, as well as the topic code. I will reveal all three to my designers. As a designer, I have the option to put in my topic code that I received from the funder so I can see the topic and requirement on my screen. As a funder, I will then give my designers 30 seconds to come up with an idea. As a designer, I have the option to click on my inspiration button in order to see some inspirations that may help me generate my ideas. Afterwards, the funder will ask the designers to pitch their ideas. The designers will then pitch, and then the funder will select their favorite idea. If I have difficulty as a funder choosing an idea, I may use an optional wildcard to help make that decision. If I am the winning designer, I get to hit pitch accepted on my phone and see a nice little animation. Otherwise, I will still be able to see a summary of how many rounds I've played and how many pitches have been accepted. Once I've played a certain number of rounds, 5 or 10, I will get a new little icon at the top to signify my participation. I may then continue to play, or I may exit the game. So this is basically how our game works, and now we'll pass it on to Aiden.
Thanks, Angelina. And now I'm gonna briefly introduce our design iterations. So for the interim, we got inspiration from the video game called Keep Talking and Nobody Explode. This is a collaboration puzzle game which led us to this idea. In this game, players need to exchange hints with each other to solve a puzzle. The puzzle is about designing an exhibition to fulfill a random generated goal, such as attracting young adults to the museum. And after discussion with our client, this idea seems not right. We received a lot of feedback, such as one right answer for the puzzle cannot spark authentic conversation. The reality is much more complex than the game. So based on this feedback, we keep moving forward, and for the next iteration, we were more focusing on the conversation itself. So we got an idea about the debate, because debate is all about the communication, and it's easy to understand. In the debate game, players needed to pick a technology first and then try to convince others the technology they picked is the most valuable one under different situations. But again, the playtest result is cold-blooded, and we received the feedback like the debate is too serious for a game, and also the conversation depth during the experience is not enough. There's only technology it's talking about. And so there's no authentic conversation as well. And based on this feedback, we keep researching and brainstorming, and then step in the final iteration. I'll hand this part to Echo.
So now I'm going to talk about the pitch party design iteration. So in the early stage of game design, we refer to some games which are simple but fun, such as some board games like Apples and Unruly Buster. We also refer to the King game from Brenda's improvisational acting class. They all have the same core mechanics, like each player will be assigned a symmetrical roles, and the winning criteria will be revealed at the end. So during the iteration process, we face some tech challenges, because our goal is to build a local mobile web game. So in the beginning, we chose to use Unity WebGL to build it, but we found that it doesn't support the mobile device, so we just changed it to Coco's Creator. But at that time, we shaped our game art from 3D to 2D. So finally, we choose to use HTML, CSS, and JavaScript to build it. And it's more accessible for players to just scan the QR code to enter the experience. For game art, we applied 2D vector art and also developed the mascot from our project logo. We also made some changes on our game UI. We created some graphics to emphasize our game theme and each topic. And also, we redesigned the layout to make the text content more clear and adjust the color to make the whole thing consistent. In addition, we added some animations into the game to make the whole experience more juicy. We used Adobe Animate to create some keyframe animation and training animations, and then exported them as GIF files and integrated them into HTML. Now I'm going to pass on it to Yuan.
So after implementing the pitch party game demo, we have conducted many playtesting sessions, and it is proof that our game can spark authentic conversations among the players effectively, and for a large group of players, they can begin the game and continue playing by themselves. So this is a record from ETC Playtesting Day. We can see that they were having discussion about technologies.
If you're polluting your river, it's the Nile River. That's very smart. But wait, you have to use technology. So who used better technology?
When you use better technology, but you didn't allow for communication.
All right. In playtesting, our game sparked so many authentic conversations just like this. And we also get some valuable feedback from our playtesting, and we have made so many changes after that. One of the most important feedback we got from playtesting is that the designers might feel inconvenient if they can't see their page topic, as our old version of designer page, it didn't have any valuable information on it. So we implemented a topic code system that each combination of requirements and the topics has a unique code. So founders just need to tell designers the code, and designers can see the complete pitch task on their screen. In addition, we also noticed that some designers may not be familiar with the topics, or they might have difficulties coming up with ideas. So we decided to give them more inspirations. So after implementing the topic code system, we put a light bulb button above it so that designers can click it to have some informations or examples about their topic. So for founders' role, some founders encountered a dilemma that they really liked one of the pitches, but that one didn't meet the requirement of wildcards content. To solve this, we arranged the wildcard window to the last page for founders and then make it foldable, so that now founders can decide whether to look at it, or they can also make all the choices by themselves. And we also added rewarding page for designers, and we put game record on the quit window. They worked as a positive feedback for players, so that they can get a sense of achievement while playing, and they will keep playing this game, and they will keep having authentic conversations during the game. So those are basically all the important changes we've made after playtesting, and now I'll give to Luca.
Hi, so then I'm gonna talk about the feedback we received from the subs. So first, because it's a web-based experience, so the animation and image does matter for loading, and we want to optimize the size and the resolution of all the art assets. And also, another major feedback we received from sub is for the designer screen, currently everything is on just one page, so it's a little bit confusing, and people tend to click next button before reading all the instructions. And also for the poster design, we may want to introduce the roles of founders and also designers. And we will also need to review the content with our client ASDC for benefit their organization and also the conference. So for the designer page, we added extra guidance and also extended the designer page. Now the player can be more clear for the whole process right now. For the content, we have reviewed all the content with our client together, and this is a brief summary of all the contents in the game right now. And for the poster, we introduced the role of designer and also the founder. We also added extra role of the spectators. So we want to encourage the attendees in the conference to observing other people to play. And this is the layout of our final game. Now I will pass on to Phoebe for the final deliverable.
So these are our final delivery. The source code will mainly be on GitHub, and we will hand in the art assets, content documents, and also a setup guide for our clients. And there's a couple lessons that we learned throughout this semester. First is simple is hard because there's barrier between gamer and non-gamer. And we are mostly gamer and tend to think that some game mechanism is simple, but it's actually not for those who don't play games. So we work really hard on making the rules simple. And second is we also learn how to handle a lot of feedbacks. For example, for our game's winning mechanism, our client don't want the game to focus on winning, but our instructor thinks that it is important to motivate the players. So we kind of combined these two feedbacks. We kept the winning mechanism, but instead of using win and lose for our button, we use pitch accept and play again. And also, the player will get trophy by playing many rounds instead of win the round. The third is the necessity of doing research and playtest early. So for our early prehab versions, they are never been really tested. So it is hard to say how they're received by the players. And for research, our puzzle doesn't really match the reality of situation, and there's no way for us to determine the right answer, so they failed. So to sum up, Peach Party is a social game that will be played at ASTC annual conference, and there will be designer and funder role. The players will come up with ideas about experience for Science and Technology Center, and the goal for our game is to spark authentic conversation and give the attendee opportunity to connect with each other. And the lessons we learned throughout the semester is simple is hard, and how to handle and analyze the feedbacks, and also playtest and research should be done early. Thank you. And we open to questions.
Yeah, is this the main focus of the session that it's in, or do you need to actually lure people in? And if so, how do you plan on luring people in to play the game?
So there will not be a specific session dedicated to it, but our client is going to be train some of their staff to like promote and help their attendees play this game. As well as that is the purpose of the poster, as well as to at least have some publicity for it.
So you guys said that you had a button during the conversation where if someone didn't have knowledge of something, they could hit the button, it would feed them information. Two questions. How did you choose which information to put there from the vast array of things that you guys could choose? And how does that affect the flow of the conversation? If I'm conversing with someone, I hit this button to read it. Just what does that actually look like? Mm-hmm. Thank you.
So for about the choosing the topics, the content inspirations, so we generated some of our own, and then we reviewed it with our client in our meetings, and then we sent them the content sheet, which was a Google spreadsheet, and then they looked through it, edited what they wanted to see on it, and then we changed our content to reflect their desires. As for the flow of the conversation, if someone else, yeah.
So for the flow of the conversation, the player as a designer will first see the topics, and then if they want to see more inspiration, they can click the button and surfing between the 4 inspirations. And based on that, they can have the idea during that 30 seconds pitching time. So. You have more questions? Oh, sorry. Yeah. Okay. Any other questions?
All right. Good morning, everyone, and welcome to WonderLab's final presentation. We are a team of 7 students. Our instructors are Chris Klug and Shirley Saldemarco, and our clients are Ian Cole and Adam Hoffman from Give Kids the World. Now, Give Kids the World is a nonprofit resort in Central Florida which provides cost-free vacations for wish kids and their families. And specifically, they have attractions at the village which are very accessible, and the newest one of these attractions is Mayor Clayton's WonderLab, which is actually currently under construction. Now, Give Kids the World is currently repackaging one of their existing facilities into the WonderLab, which will be a makerspace-like environment with a focus on STEAM, or science, technology, engineering, art, and math. Now, within the WonderLab is this space called the Game Portal, and that's the space that our team is working in. It's a 15-foot diameter circular space with projection-mapped walls and spatial sound. And our original planned deliverable was to develop an experience to be installed into this space, as well as designing a technical platform for the space. However, our team faced several challenges, and we made several mistakes, especially early in the semester. And as time went on, we realized that we were not going to be able to deliver this on time. So at week 12, our instructors advised that we pivot instead to a pre-production package and documentation in order to support a future ETC team. And so our final deliverable instead is a prototype demo, as well as a development toolkit, a design package, and full documentation of everything that our team did this semester, including assets, both sound and art. So to clarify, for the rest of our presentation, we will be dividing it into 2 main topics. First, we're going to talk about our planned experience and all of our work up through week 12, followed by our final deliverable and a reflection on our semester post-pivot. And now I'd like to invite Yuchan to talk about our development timeline.
Yeah, thanks, Laurie. So at the beginning of the semester, we don't have any design constraints, so we started to do some background research. Yeah, and we collect all the previous ETC Give Kids the World project and to see like what they have already been done. And we then came up with a drastically 2 different directions to pitch to our client. And a few things they like are the multi-user, the problem solving, the physical control, and also less linear experience so the kids can join in the middle. Yeah, and we then visit our client to Give Kids the World to see like what's really inside it because we want to fit our experience into it. Like what we got from our client is they want to teach kids like what's in the village. And we also acknowledge that there's some IP existing that we can use, which is available. And finally, we came up with 2 concrete ideas, each with a paper prototype. One is an interactive playground, and another one is the train repairing and building system. Yes, so we pitched again and found out that the train fantasy really works well because the building has a marker space. And we also want to embrace more explorations, so there's actually no right or wrong answers. So that way we can attract a broader audience. And then we came to the technical platform. We started to develop, including the vibe tracker, the Kinect, and also a costume motor control. However, the vibe tracker and the Kinect have foreseen problems such as really hard to keep track of the guest data and really hard to maintain. And moreover, it's really hard to build a reliable system without really accessing to the building like us. So finally, we decided to use the RFID chip and also the custom mounted control. So we use RFID chip to identify guests, and our guests mainly interact with our experience with the physical control, including the buttons and the sliders. Yeah, so combining with the train building fantasy and also our technical platform, we finally got a concrete idea and a plan for our experience. So I'm going to pass on to Muru.
Thanks, Yuchan. We were developing a modular building experience where wish kids can design their own trains and test them out in a virtual environment. Wish kids enter the room and get an RFID chip that they can tap on the bench to activate their experience. Each bench has a unique station with different mechanics and control scheme. We recommend them to follow the direction, but there's no limitation on which one they go first. The last bench is a simulation station where kids can actually see their train running around. This is how we divide the room. The first one is gear station. This is the place where kids can design the power factor by choosing the different combination of sizes of gears.
In the whistle station, kids can design the whistle by choosing different instruments and recording a short melody. For the color station, kids can select the different section of the train and change the RGB color. For the final simulation, this is the place where kids can see how the 3 designs affect the train. And to see how the gear design affect the train, different combinations of gears will lead to the different speeds and torque, which will cause the train goes to different passes. Exploring all the passes is the major incentive for the iteration and the replay. Now I'm going to introduce Xinyi.
Thanks, Muru. So this is our final build before half. By then, we only have 2 functional stations, and because after half, we continue building our platforms. By now, we have 4 functionally ready windows, and we have completed all the physical and digital prototypes. And this is our final physical setup for our project room to test our experience. We've conducted 2 rounds of playtests through our target audience. The first playtest we went to assemble to test out with our target audience in age range of 8 to 10. By then, we have 2 stations ready and all the physical controls mapped to our Unity engine. We got our feedbacks that kids generally like our games and found the games is interesting and intuitive. However, there are a few changes that we made through this playtest. We moved forward towards larger table, and then we added a few more whistle notes to our whistle station, and we also added a few more UI elements to the experience. And finally, we decided to make a 3rd-person perspective for our final simulation stage. And the second playtest with our target audience is on our ETC playtest day. And we have 5 groups of playtesters to come to our ETC project room and then to test out our experience. And from the feedbacks, they generally like our physical interactions, but there are still a few more changes that we need to work on to each of our 4 stations. So the changes that we have made through this playtest is that first, we added a few more distinctive background to the first 3 design stations. And next, we limited our whistle note through this in our whistle station to make it less noisy. And we figured out, after these 2 rounds of playtest, we figured out our biggest problem is that kids are not able to understand our experience. Like, we have 4 windows functionally ready, and kids enjoy making, playing with physical buttons and controllers. However, they are not able to make the connection that these 4 stations are not 4 separate mini games. Therefore, we're constantly getting feedbacks that they like our physical input, they like our playing with buttons and controllers. However, these feedbacks are not able to help us to move forward. Given that we only have a few weeks left and there is still a huge gap between our project and the installation-ready product, it was suggested by our instructors that we need to pivot our delivery to only make it a pre-production package. Now I'm going to pass to Wish to talk about more.
Thanks, Xinyi. So we are going to deliver a pre-production package, which includes a documentation and a VR toolkit and also a demo video. So for the documentation, we are going to, as requested, we created a single standalone file, which includes all the design process we've made and all the changes we've made throughout the playtest, and how to configure the Unity project, and also we draw the circuit diagrams, and also we stress where all the assets are allocated. And this is a VR toolkit that can simulate any panoramic experience inside a circular space. Because one of the takeaways in this semester is that even though we try to recreate a space inside our project room, there's still a gap between 4 separate screens versus a single panoramic screen. And in our case, it seems that the kids have difficulty understanding that they are creating one train rather than the 4 different experiences. And also, VR is more portable, so we can easily bring our experience to the place such as Assemble, so we don't have to wait until the ETC playtest day to bring our guests inside our building. And also, we can send our build to our client. So, actually, we brought out this idea to our client before we started to develop. And after we finished our documentation, we started to develop, and it only took less than a day. So it is a toolkit is capable of auto experience, so you can simply change the camera view to your experience. And we also provide different input methods to simulate, so you don't have to deal with the physical wiring stuff before you go too far. It is another lesson we learned in this semester, that if we can playtest earlier, and we can find the problem more earlier. So really hope this VR environment could be a tool that can help the future team to conduct playtest. And here is a pic of the demo video. So it is a view what we will see in the VR space. So you can use your controller to simulate something like buttons and the MIDI keyboards. And next, I'll pass to Hongzhou to talk about our postmortem.
Thank you, Wish. And we know we have changed our plan and could not deliver what we originally planned for, but this is still a great learning experience for us. And we would like to share our reflection by summarizing one thing we think we did well and one thing we think we still can work it in a much better way. Looking at what we've accomplished this semester, one thing we think we succeeded at is working with our client to meet with the design constraint and account for uncertainties. We started off with 0 constraints. The building doesn't exist. There's nothing set up for the room. And so we use multiple rounds of pitch, tool, and field of research to help with our client figure out which is the best experiments for the room. And during the semester, the plan for a room has changed multiple times. The degree of the projection went from 270 to 180. The shape of the room went from a 16-gun shape to a smooth circle. And the resolution of the projection hasn't been decided yet due to the uncertainty of the projection provider. And we were able to change our design and implementation to accommodate that. And that is what we think we did well over the semester. And next, I will give it to Jingyu.
Thank you. So over the semester, we have, talking about the pitfalls, we have been summarizing a lot of reasons that this hasn't been as successful semester for our team. But the biggest thing we found that could have been handled significantly better is playtest and iteration. And I'll talk about the reason. So over the semester, we sort of adopt this classic waterfall process of we took the first 4 weeks primarily in design. And once we have a concrete idea and our clients seem fairly happy about it, we just went straight into development without examining any potential risks. This has led to 2 further pitfalls. First, the platform we chose was completely custom, and we did not account for the robustness of it, which leads to us constantly having an issue connecting our physical prototype to our digital one. Sorry. And we did not have a backup plan to keep develop or playtest when the platform is not working. So we ended up wasting a lot of time either trying to fix the platform or waiting for the platform to be fixed. Secondly, although we emulated the physical space fairly well, something we failed to do was simulate the experience as if how it will be installed in the final venue. This has led to a huge obstacle of our target audience trying to understand our experience. So those 2 pitfalls led to us having inefficient playtests over the semester, and having insufficient playtest data led to us not being able to validate our design or make any major iteration after the initial 4 weeks. So that being said, we also thought about how we should have done everything differently if given the chance again. First and foremost, we should playtest earlier, more often, and more effectively. We think this can be achieved by adopting different strategies to playtest or prototype when we don't have the complete game 100% working. The VR toolkit is something that we build based on this finding, and we hope it can be helpful for the future team to conduct more effective playtests earlier. Secondly, we should embrace more of the discovery side of this project to account for the amount of uncertainties we have faced over the semester. If we didn't adopt the strategy of 4 weeks pure design, 10 weeks pure development, but instead move on to experiment with more platforms, prove that prototype, and
analyze what's the best platform or experience that can go inside the room, that will be a more helpful deliverable for our client, given that the space is not ready for installation at this point. Last but not least, we thought of those questions or problems can be much better solved if we reach out to our instructors earlier in the semester to seek help. Instead of just working on our own solution and hoping it will turn out well during playtest, which, according to our previous explanation, completely did not happen. So that summarizes our presentation. Again, this hasn't been a very successful semester for us, but we're ultimately grateful for our instructors and client helping us to turn this from a completely crashing to a soft landing, and we're now open to any questions. Thank you.
Can you talk about the audio for 4 stations in one single space, and maybe what your pre-production package talks about in terms of audio design for that space?
Yeah, so the audio fitted for the space has not yet been determined, but what we have designed for is that each station will have its own kind of centralized audio on 4 different audio channels. And so for each station, there would be like a set, this channel will represent this station, and then there will be a spatial speaker in that area that would translate to that. It's just that those technical details haven't yet been determined.
In your VR demo, can you add NPCs or just blocks that represent other guests in the area so that when people are designing in there, you can get a feel for how this would actually feel with people all around me?
Yes, so this VR toolkit is completely modular, and we have modeled out the entire space, the game portal, based on the interior design package we provided by Give Kids a World. So that this is completely modular. You can change the table layout, you can add in more avatars, you can add in modular control panel that can functional and link to the digital experience that will be projected in this virtual world.
So is there only one RFID reader? So basically one train is worked on at a time? Or can multiple kids be working on different parts of the train at the same time?
Yeah, there are actually 3 RFID bench on each station. Yeah, so like at least the 3 kids can work at the same time. So like they can hold different RFID, and if each one they tap on the bench, they can create their own trains and have their own experience.
Yeah, so just to clarify, there's an RFID reader per bench, and each kid would be given the chip in which they can scan into each bench once they're in the space.
Okay, thank you.
Time for one more.
So what considerations did you make for wheelchair accessibility for this pre-production package?
Yeah, so for wheelchair accessibility, we conducted, especially our earlier play test, with wheelchairs that we had in our project room. We also designed for lower tables without so much reach so that you can pull up to it and then kind of reach anything on that table. It's also, there's nothing kind of mounted in the middle of the bottom, so you can wheel up kind of so that your legs are underneath the table, and you can wheel under the table so you can reach things on that surface. Yes, so the VR is a simplistic representation. The actual table designs have that layout, which is in the pre-production package.
All right, thanks, team.
Thank you.
Hi, good morning. We're Team Portal Harmony. I'm Tuesday Becker, and I was the director and co-producer.
Hi, I'm Sandra. I'm character artist and co-producer too.
Hi, I'm Joy. I'm the environment artist. I also help with story design.
I'm Shinu. I'm the animator, rigger, and motion capture handler.
I'm Rick, the VFX artist.
And our faculty advisors were Scott Stevens and Ralph Fituccio. We collaborate with Attack Theater Studios in Lawrenceville, Peter Cope, Dean Toney, and Sarah Zielinski was our wonderful dancer. And as a recap, our project was linking motion capture with Unreal Engine to create a roughly 3-minute animated music video. And the song we chose was This Time by Brightside, a local Pittsburgh band.
And since half presentation, we had conversation with the dancer and also with faculty about our angle and our method. Based on the technology and capability of the hardware, we have some changes around the motion capture animation and also story design and also transition and visual effects in the story.
As a character artist, at the very beginning of the design stage, we used to have 2 different character models, designing 2 different reflection and in the mirror. So because of the scope and some technical issue with the mocap suit, since we only got 1 mocap suit for capture 1 dancer, we had dropped the first character in the first picture. And then with the development of the storyboarding, we have decided to change her outfit too. We initially changed her from a jacket person to a painter artist. So you can see the development of the character, and the character on the right side of the picture is the final design. And also, with the development from ZBrush to Maya, we have run through different topology progress. You can see the difference between topology on the first sweater to the end sweater texture, and the one in the last pictures are the final rendering engine. Since we worked in 2 different software, maybe 5 to 6 different softwares, and the final end engine we're using is Unreal to render everything out, there was a link broken between different softwares, especially from Maya to Unreal. There is always some problems. The most serious we got was the rigging method from Maya wasn't classic, so it wasn't being supported by Unreal. We have worked out a different method to export it in a different file formation to keep all the vertex animation. We also discussed more in groups between me and Shinu. We are character artists and character rigger and animator. So this progress took back and forth, and finally we did it. So we believe it's a feasible and easy solution to solve everything else in Unreal Engine and Maya.
Yeah, so we learned a lot when it came to motion capture and cleaning up motion capture data through a lot of research and trial and error. And we definitely learned a lot when it came to finding the right motion capture system. And when we did find it, the Perception Neuron 32, how that system worked and how we could use it in our project. But we learned the most when it came towards developing our implementation and cleanup pipeline, which proved to be really effective and really efficient, cleaning up 28 scenes worth of data in only just a week. Although we accomplished our biggest concern, which was efficiency and whether that efficiency will actually give us usable data, our biggest struggle was definitely getting that data and polishing it so that way all the noise and like jitters would be removed completely from the motion. It was a stressful and time-consuming process, but we did polish the clips, and although they are not perfect, we can definitely say they are a big improvement compared to the original raw data.
Yeah, so I began my process storyboarding alongside the team, and I did probably about 4 to 5 different iterations of the storyboard. We made changes based off of faculty feedback, as well as Shinu did a lot of testing at the beginning to see what was capable with the motion capture suit that we had. So initially we had a lot more close-ups on feet and things like that, and so we eliminated that just because the feet were going to be difficult to clean up. And then following that, we had a meeting with the dancers, and the dancers basically talked to them about like what they found interesting about the storyboard that we had and the song. And so we decided to lean more towards this idea of a duet or duality between our protagonist and like a mirror version of herself. Behind me is the Unreal sequencer. So basically, Shinu would clean up the clips, give it to Sandra, and then Sandra would import them into Unreal Engine. And then I would drag them into the scene and place them in the environment and change the transformation, the XYZ axes based on like where we wanted the character to be. We decided to capture the animations separately in smaller clips per scene, per sequence, different motions. So we had like 28 in total, like Shinu had said. And after importing them into the scene, then you go through into the sequencer and you can keyframe them individually. You can keyframe camera movements as well, you know, focal length, aperture. You could set an object in the center of the scene and have it rotate perfectly around the object in order to create the camera motions. I think a difficult thing was some things are just easier to edit in Premiere versus the sequencer, because we made one change for a keyframe, it would shift everything else down, and you would have to individually correct all of those. So some things like clip length and were just easier to fix up within Premiere or a different editing software. And yes, I'll pass it off.
So here you can see this is how the engine works with the sequencer, and we can key almost everything inside the game engine, almost like Premiere, but it is we have more dimension and more capability. Since we have decided on the mocap hardware, we also decided on making a music video in the start of the semester. So we have to design a story and actually render it out for the final product. We went through the pre-production and production in 14 weeks, which is typically done in a year-long animation for 2 semesters. We're also talking with dancer faculties and also our fellow students about how to design our stories. And after iterating on the storyboard, we have set a final theme for our story through the half semester, and then starting the kind of like incorporating everything inside the game engine. We are creating a story based on our storyboard, reference the drawing, and also the idea talking with our dancers. And here you can see is a demo video comparison between the mocap footage and the final render inside game engine. And this is a preview of the asset we created inside Unreal using ZBrush and Maya, and also Marvelous Designer.
And here's our production pipeline design. Firstly, we use Maya and ZBrush for the modeling, and then we use Substance Designer and Substance Painter for the texturing, and we use Houdini to simulate the VFX, and we put things together in the Unreal game engine and render the animation. And finally, we use Adobe Premiere for the video editing. And also, we created some VFX linking Houdini and Unreal. For instance, we created this paint in Houdini. We simulate the fluid particles and generate the surface and export them as the Olympic geometry cache into the Unreal game engine. And as for the chessboard destruction, we simulate it in Houdini and export it into Unreal. And also, we use Niagara system in Unreal Engine to simulate the particle effects like the butterflies. And here's our final render.
And we want to thank all the faculties who provided suggestions for our soft opening and generous suggestions for art design, camera design, and everything else. And now we're open to our QA session. And
you talk about the song and how you designed the song and what your approach was there?
Yeah, so I listened to the song a lot and looked at all the lyrics, and basically our interpretation of it is we decided to tell a story about someone. The song itself is about working on your craft and your personal creativity and stuff like that. And so we decided to take it as a painter. We wanted something very visual, something that we could play with the idea of like paint and color, and so we decided to go with a painter. And then as far as the editing goes, there's some rhythmic things, so certain moments in the song that I wanted to hit with certain cuts and things like that, yeah.
Yeah, we also, because it is a creation process told in the story, which is similar to kind of like a writer's block, we also experienced a similar process in making all of this music video, so we kind of use that feeling as well to help incorporate our story.
So project pitch, you had a specific goal in mind, the pipeline, right? There's a lot of personal, emotional things that you've accomplished, a lot of good looking work. Did you hand forward knowledge? Like, did you add anything to a wiki, or what is the knowledge that you're handing forward to the next animation teams that are going to do what you're doing?
So everyone in our team has a different knowledge in different skill sets. Like I'm specialist in modeling, and he's specialist in VFX, and we have animator rigger. So we want to help future students to understand how the full production gonna be, instead of having individual roles in identical areas. And also we have different technical issues happening in this project, and we also document it. For example, there's something I mentioned before, like something that Unreal doesn't support from Maya, and something Unreal doesn't also support from Houdini. This is something we want to tell the future students. How should you do things? How should you fix bugs in any potential pipeline that you want to work now?
We also, like from my point of view, I also produced like a 20-page guide and documentation on how our pipeline works and how the motion capture system works. And any student...
That is in your archive or on the wiki?
It's uploaded with into the Google Drive. Yeah, the archive, yes.
So you said you had a lot of problems with mocapping. I was wondering if there was a time that you thought you just do the performance and rotoscope it in.
Yes, we did actually implement a lot of rotoscope animation when it came to cleaning up the data. There were some problems that were really easy to fix, just a matter of going into the data and altering the data points to get the motion that we required. But there were some where, for instance, say like the feet would not line up with the ground. And so we had to, most of the time the motion capture did a really good job tracking the feet onto the floor, but there were some times when some noise was produced and we had to use rotoscope animation to correct it into having the feet touch the ground.
Okay.
And you can see from the picture at your left corner, it's she doing this, and then the motion capture system will automatically consider your feet is on the ground and then do a top-down reverse, then whatever you actually captured. So that was a pretty serious question. If you want to climb on a ladder, it will think the first step was the ground and never make you that climbing motions with height. This is really doing a bad job in measuring heading.
Yeah, but my definition of rotoscoping was more like you have her perform in front of a green screen and then get her live image into the scene without the mocap. Have you guys, was mocap that important for you guys?
Yes, it was actually really important because for our project we wanted to actually use motion capture and make use of this technology and make sure that we create a pipeline so other students in the future can use this technology and understand the limitations that we went through, and also give them the ability to, if possible, like for future teams to understand these limitations and know and think of other ways of how to get around them or even work with them or even fix them. So,
Cool. Thank you.